Okay, so in fact, the amount of solar input decreases with latitude. Okay, decreases with latitude. Further you are from the equator, less amount of sunlight that you have. The place that has more direct sunlight is what is called the tropics. The tropics is regarded as the area 23.5 degrees north and south of the equator. Okay? Now, why 23.5 degrees? What is significant about that? That is the angle at which the Earth, with regard to its orbit around the sun, happens to be tilted. Okay? So it's not standing straight up with regard to the orbit around the sun. So if this here is the sun, even though it's rectangular, let's still pretend it's round. You know, we're like this. We're tilted. This angle here is 23.5 degrees. And so if we're at spring, first day of spring, when the sun is at its highest point, then it's going to be directly over the equator, okay? Right up there. Here, you never find the sun straight up, okay? And the closer it is to being straight up, the more intense the sunlight, okay? But as we move through the seasons, okay, so let's say this is the first day of spring. Yeah, let's do it this way. First day of spring, then we move over here to the first day of summer, June 21st. The northern hemisphere is tilted toward the sun. At that time, the sun will be at high noon, solar noon, would be straight above people who are standing at the Tropic of Cancer, which is 23.5 degrees north latitude. Then as we continue around here, reach September 21st, once again the sun would be straight over the equator, okay? Because I'll show this in a moment. Then as we move over to December 21st, it is the southern hemisphere that is pointing toward the sun, and we're leaning away, okay? And so that changes the distribution of sunlight. So it's around the equator and the tropics that the sun has the greatest input, okay? Whereas it has less input on the Earth as we go further north or south from the equator, from the top tropics. So this is a figure from your textbook, sort of showing this. The sun is so big, it is so big, and that we can consider the rays of the sun being parallel, okay, as they hit the Earth. And so this is the situation that you'd have on the first day of spring and the first day of fall, is that the sun, someone standing on the equator, they're right here, okay, standing like that, and the sun would be directly overhead at solar noon, all right? Whereas someone up here, and notice that this, too bad I didn't bring a flashlight, but you've done this with a flashlight. You put a flashlight straight parallel to the board. What you have here is a nice bright circle of light, but if you tilt it just a little bit, then that is spread out over a larger area. And so, but the amount of energy coming out of the flashlight is exactly the same, but it's spread out over a larger area. And therefore, there's less intense solar input per square unit area. And that makes a difference with the temperature, okay? Warmer temperatures here, all right? And if you look here at this, this is based on means. Mean temperature, maximum mean temperature, and this is the scale you're looking at, and minimum temperature. You notice here at the equator, between the maximum mean temperature and minimum mean temperature, there's not a whole lot of differences. But the differences increase as you go away from the equator, especially in the northern hemisphere, okay? And this is the difference here between the northern hemisphere and the southern hemisphere mostly has to do with land mass, okay? There's greater land mass up here in the northern hemisphere than in the southern hemisphere. Water doesn't, since it has a high specific heat, it doesn't heat up and cool down very rapidly, whereas land does. And so the more land there is, the greater the differences in temperature. And that influences the circulation of everything. Now, I already demonstrated this. You know, this is exactly what's happening as the sun goes around. decided to draw some of my own, sort of to illustrate this. So this is, normally I don't give these out to students, but this time I did. So what does it mean to be 23.5 degrees north latitude or 40 degrees north latitude? What does that mean? Okay, what does it mean?
It's like you're 40 degrees like away from the equator, is it?
Well, to have an angle, you have to have two sides. So what are the two sides?
Equator and the...
Yep, so if you're standing in the middle of the earth, which you can't, but if you're standing in the middle of the earth, the angle from the equator to a point on the surface, that's what we're talking about, okay? So this angle right here to this yellow line, because why am I saying 23.5, 23.5? Because this is the Tropic of Cancer, this is the Tropic of Capricorn. It's only in this zone that the sun will ever be straight overhead, okay, at some point. That's the only time that you go further south, the sun will never be straight overhead. You go north of this, the sun will never be straight overhead, okay? Now where we are here in California, it's a little bit more than 37 degrees north latitude. And so being 40 degrees north latitude means that this angle is 40 degrees, okay? All right, so these are the rays of the sun, parallel. And so for someone standing at the equator on this particular day, these 2 days, March 1st and September 21st, the sun for someone at the equator at high solar noon would be straight up, okay? For someone standing here, 23.5 degrees north latitude, okay, they would be like that. The sun at high noon would be to the south, and the angle from straight up to where the sun is 23.5 degrees. Someone who's standing at 40 degrees north latitude on those days, the sun would be located from straight up to the south, wherever south is that way, I guess. Straight up, the angle to the sun is 40 degrees. Or another way of stating it, the sun is 50 degrees from the horizon, okay? And so it's coming in, the light is coming in at an angle. Not only is the angle important, let's go back here to another figure, this in here, is that also the amount of sun, the distance that the sunlight has to go through the atmosphere is less here than up here. Because the sun's coming in at an angle, it goes through a thicker, longer track through the atmosphere. And of course, there's molecules in the atmosphere that absorb the light. Okay, so less energy is hitting the surface. Okay, so let's go to summer, with summer for us, June 21st. This is how the relationship between the solar energy and the Earth would be. So someone at 23 degrees north latitude at high noon on June 21st, the sun would be straight up. For us, or if we were at, 40 degrees north latitude, well then the angle from on June 1st, where the sun would be in the sky, would be from straight up 16.5 degrees. It's pretty high, okay? Now where do I get the 16.5 degrees? 40 degrees plus tilt of the earth, 23.5. Gives you that, this angle would be that 65.5 degrees. Let me state this again, because we're talking about 16.5. Where do you get it? You would take 40 minus the tilt of the earth, 23.5. 40 minus 23.5. All right? Whereas someone at the southern, the Tropic of Capricorn, 23.5 degrees south, they would see the sun to the north, okay? It would be to the north, and the angle would be 47 degrees from straight up. Where did you get 47? They were already 23.5, and now you add to that the tilt of the earth, 23.5. And that gives you that angle right there.
So it goes away from the earth, basically, so that's
Yeah.
why you added.
Yeah, so now if we go, take us to where North America is experiencing winter, then at this time, the sun would be straight overhead for someone who's 23.5 degrees south latitude. And for someone, where would it be for someone who's at the equator?
From someone from the equator, since it is already 0, so it'll be 23.5?
23.5 degrees off from straight overhead. And for someone who's up here, 40 degrees, this angle, 63.5 to the south. In other words, take 90 minus that, it's about 16.5, or no, what is it?
It would be, well, you add 40, and then since it's going away from
Yeah,
Earth, it'll
well,
be
you see, the
42.5.
sun isn't very high in the sky. And pay attention to that when you're in winter here. Where is the sun? It's not very high in the sky, but in summertime, it is. Not only that, but the amount of time that the sun is up is shorter in the winter than it is in the summer. So you get more sunlight. And hence, that's why it's warmer, okay? So if I did these from a different perspective, someone who's at the equator, they would be seeing through the sun, through the year, they would be seeing the sun at high noon, just simply moving 23 degrees to the 0.5 to the north, then back to straight overhead, 23.5 degrees to the south, then back to straight overhead. So the sun is always really high in the sky, intense input of solar radiation. Whereas if you go to the Tropic of Cancer, a person there would, throughout the seasons, would see the sun only at the first day of summer, being straight overhead. Then it would move 23.5 degrees south, and then another 23.5 degrees south, and then back and back. And southern hemisphere would be just the other way around. Someone 40 degrees north latitude, they'll never see the sun straight overhead, okay? The highest it will be in the sky, be just 16.5 degrees from straight overhead on June 21st, but in first day of winter, it's going to be way low in the sky, and therefore that's why it's cold, and because of not a whole lot of solar input. Now this fact influences air circulation and moisture patterns on Earth. And this here figure is just showing a generalized circulation pattern, but what happens, and in fact these air zones, they shift north and south with the seasons by 23.5 degrees. So this figure here is showing it like on March 21st, September 21st, when the sun is directly over the equator. Now what happens here with this input of solar radiation is you get a lot of evaporation, okay? A lot of evaporation, so the air is moist. Furthermore, as the air heats, it expands. What happens to a gas as it expands?
It takes up more space.
Well, it becomes lighter, right?
And
Okay.
it goes up.
And so therefore it starts to rise. It goes up, okay? So as this gas is going up, it is cooling. This moist air is ascending and it's cooling, okay? It's cooling for two reasons. One is because higher in the atmosphere it's cooler, but also there's less pressure and it expands. What happens to what's the relation between gas, its temperature, and its volume as it changes volume? As a gas expands, what happens to the temperature? It goes down, okay? Sometimes get yourself a aerosol can, it's almost empty, and you push the button, letting out all the air, then feel how cold it gets, okay? The temperature goes down. So as a gas expands, it cools. Now this air that's going up is loaded with water. It's 100% saturated. But there is a relationship between the air's temperature and how much absolute water it can hold, okay? The hotter the air, the more water it can hold. But that relationship drops as the temperature goes down. Okay, just go to this right here first. So this is showing the total amount. Okay, when we say 100% relative humidity, it's talking about the maximum amount of water that the air can hold at that temperature. okay? It's saturated. And you notice here that if it's warm air, it can hold, this is the amount of water that's in the air in terms of kilograms, grams of water per kilograms of air, is that it can hold quite a bit at a high temperature. But notice that as you go down to low temperatures, cold air does not hold a whole lot of water. Okay, now, as this gas is going up, let's go back, as it is ascending, okay, it's warm, saturated, it goes up in the atmosphere, the gas is expanding, temperature's coming down, and what happens when the temperature comes down and you have 100% humidity in the air, you get cloud formation and rain, because the air can't hold the water anymore, and therefore it starts raining. You get a lot of rain here in the tropics, okay? Eventually, as this air gets up, it cools, but it will reach a point where it'll split and move in the high atmosphere north and south, okay? So here we've lost a lot of water, it's rained out, and as it moves north, well, because of less insulation, that is from the sun, it's cooling still, and so you still get rainfall. So in the zone close to the equator, there's a lot of rain, all right? Then at about 30 degrees north, 30 degrees south, this air mass that's high up in the atmosphere, it descends, starts coming down, all right? So now it's relatively dry air, but now we're compressing the gas, because as it's coming down, the gas is being compressed because of the weight of the atmosphere. So what's happening to the temperature? It increases, and its ability to hold water increases as well, but it's already dry air, okay? So it becomes even drier, okay? It becomes even drier. By the time it hits the ground, it's pretty dry air, right? And it can take, it has a capacity to take up a lot of water from the surroundings. If you look at a map of the earth, you'll find that the world's deserts are mostly settled around 30 degrees north, 30 degrees south latitude. And this is why. Because of this dry, descending air mass, okay? Now, once this air mass comes down, in fact, this is called a Hadley cell. Put that up on the board after the person who first discovered it. And this is sort of idealized because there's a lot of factors that can alter it, okay? Hadley cell, this circulation. So as this air then comes to the surface, it will move along the surface toward the south and toward the north. So it divides, goes both ways. And it's dry air, but then as it's moving, it's picking up moisture from the surface, from lakes, rivers, trees, etc. And once we get up to 60 degrees north of the equator, it will rise again. So this is relatively moist air now because it's picked up water as it's moved along the surface. And now it ascends, and we have another type of cell here. It's called, don't remember exactly, it's not a Hadley. Hadley cells are these two here. But as it's going up, it's now moist air, relatively moist. And so as it goes up, it expands. As it expands, it cools. As the air cools, its capacity to hold water decreases, and you get rain, okay? Now, where are the world's conifer forests? Mostly. Conifer forests are situated in this area, north and south. Okay, now this doesn't give as much rain here as you have in the tropics. You get a lot of rain here in the tropics, okay? But still, this is a zone of somewhat higher rainfall. Temperatures are cooler too, so the availability of water is, evaporation there is not as great. And then once again, when this gets up in the high atmosphere, we get this circulation, such as that. My whole point here, because of this circulation, we find tropical rainforests around the tropics, in savanna, in the areas of 30 degrees north and south. This is where deserts are largely situated. And 60 degrees north and south is where you mostly find conifer forest, okay? And so it's not accidental where things are. Now, there's other things this is idealized. Now, and although this particular figure is showing these winds going, we got this other one here that shows a little bit better too. But lets a circulation look like it's just north and south. Really, because of the rotation of the earth, you get a Coriolis effect. And so these winds really, on the surface, are going, in our zone, they're mostly coming from the southwest, flowing northeast, okay? Because of the Coriolis effect. Okay? All right. One other thing I had here, picture I dug up, is this is showing basically what those Hadley cells are doing like. As it goes up, moist air, as it ascends, then we get cloud formation because the gas cools and the capacity to carry water is less, we get rain. And as it descends, we have very dry air, 30 degrees north, and this is where we have the deserts. Okay. And this is just another figure that I gave you. So as this air near the surface, as the gas extends, what is causing the pressure changes is the weight of the atmosphere. Okay, the weight of the atmosphere becomes less and less as you go up, and the gas will expand. And as the gas, if it's rising, then it will expand and cool, and we get rainfall. But there's also local factors that can affect the climate. So what I just gave you was a global pattern of air circulation, but there's still local factors that can influence that pattern. One of them happens to be ocean currents, where they happen to be. Okay, so here on the coast of California, our climate is relatively mild. We don't have real cold winters. And we don't have long, hot summers. It does get hot, it does get cold, but here along the coast, how often do you see snow? We see snow up on the hills, but not too much down below. So it stays pretty mild and relatively cool. And this is because if you stay at the same latitude and go over the Sierra Mountains, or even go over into the Central Valley, temperatures can be pretty hot, okay? And one of the reasons it keeps us cool is because of ocean currents. California current out here is coming from the Gulf of Alaska, and it's cold water. Whereas if you go all the way over to the other side of the United States, New York and everything, they have the Gulf Stream, which is coming from the equator, and therefore that water is warm water, and it keeps things pretty warm there. Okay, it's ocean circulation, and this is driven by winds. Surface winds are causing this water to move around. But here in California, we're getting this current, cold water that comes down, whereas over here, they're getting warm tropical water that is warm, it goes all the way up into the North Atlantic and releases heat into the air. Now, have you ever been up here, well, this doesn't show, Hudson Bay, okay, in Alaska? How many of you have been in Hudson Bay during the winter? Probably not, but what do you imagine it's like at Hudson Bay during the winter?
Cold.
It's very cold, okay? But that's at the same latitude as London, England. Now, how many of you have been at London, England in December?
No, I went in summer. My parents don't want to go in December because they don't like rain.
Okay, well,
It's snowing.
does it get terribly cold in London during the winter?
No.
Not as cold as it does over here, and that's at the same latitude. Same latitude. What is the difference? This warm water coming up here and releases this heat into the air. Okay, and that's what's keeping Northern Europe, relative for as high latitude as they are in, that is what's keeping them warm. Okay. So these ocean currents do make a big difference. In South American summer, I was down here in Peru on the coast 2 years ago before COVID came in. And even though it's not too far from the equator, Lima, Peru, it's relatively cool there. And that's because of this cold Humboldt current that's coming up the coast of South America. Close to the water, it's relatively cool because of the influence of the ocean water. Now, even big bodies of water can have an influence on climate, large lakes. Let me jump back here to the map. Winters in New York, New England, how much snow do they get?
Like 2-3 inches.
Compared to over here?
Not
They
as
get
much.
snow, they all get snow,
It's not as
but
much.
they get a lot more snow over here. The storms are coming from up here, going this way, okay? So why is it that they get more snow over here than over here in Minnesota?
Like the Great Lakes?
Great Lakes. So those storms are moving over, we get evaporation off of these Great Lakes, and therefore that contributes to the precipitation that falls downwind from where the storms happen to go. So large lakes can have a big increase in the temperature or affect one thing, it can moderate the temperature, but it can increase the rainfall downwind from where the lake is. So these local factors have some influence. Mountain ranges have a big influence, okay? So if you've driven here from the coast, go over to Reno, Nevada, okay, what type of vegetation do you have going up the Sierras? First of all, you're in grassland,
Yeah.
okay? Or at least originally it was grassland, now it's mostly houses. But then as you start to go up, you go through oak, mostly oak, then into oak pine, pine fir, and then go down the other side to Reno. What's it like on the other side?
Isn't it like dryish?
Dry.
Yeah.
Okay, now why is that? Our storms are coming from the Pacific, okay? So as they come in here, there's moist air, and those mountains push the air up. So what happens to the gas?
The gas stays.
No, the air, okay, it's a gas, but as it's pushed aloft, what happens to it? It expands. It expands. Because anytime you go up in the atmosphere, there's less pressure and the gas expands. And what does that do to the temperature?
Drop.
Temperature goes down. What does it do to the capacity of the air mass to hold water? Decreases. You get rain. So as this moist air is pushed up toward the top of the Sierras, you get, the air expands, it cools, you get precipitation. And then as it goes down on the Nevada side, we've already squeezed out a lot of the moisture already. And so all that has fallen on the western slopes of the Sierras. As we start going down, now the gas is being compressed and it's warming up, it's heating, and its capacity to hold water increases, but it's already very dry air. And so when it gets down here, it can suck up a lot of moisture from the surroundings and still not have any rain. This is called a rain shadow, and you find it everywhere, okay, where there are mountains, okay? They produce, especially if the ones are on, like the Rocky Mountains and the Sierra Nevadas, this is a very common thing, that the south-facing slopes, well, no, I'll talk about that a little bit later. Let me see that, rain shadow, that's the word I'm looking for. Okay, so you get these rain shadows because of these mountains. And even with the coastal mountains, we get a little bit of that, you know, because here in Fremont, you get less rain here than Berkeley. And why do you think that is?
Berkeley is near like.
What would be preventing, and in fact, if you go down to San Jose, they get even less rain because of those coastal mountains over there. Okay, across from Berkeley is Golden Gate. You know, there's a gap there, and therefore more moisture can make it over. But you go down to Santa Cruz on the other side of these mountains here, it's pretty green. They get a lot more rain there. So it is a rain shadow, but it's not as stark as with the Sierra Nevadas because they're high. And we see that, how many of you have ever been to northern Chile?
Northern Chile.
You guys don't get out much, do you?
We have to
Okay.
study.
Okay, what do you know about, the landscape in northern Chile?
Mountain, I
Hot.
think.
Well, the or not the Himalayas, the Andes are over there, right?
Oh,
But I'm talking about coast.
No, I have no idea.
coast, isn't it very coldish there?
Anyone heard of the Atacama Desert?
Kinda.
It's one of the driest places in the world, okay? Real dry. Let's go back to the map. You didn't know biology involved a bunch of geography, did you? Yeah, right here. One of the driest areas in the world. There's some places here in the Atacama Desert that it hasn't rained for 10 years, okay? They haven't got zero rain. Why is that? The winds, storms down here are coming from this direction. In North America, they're coming from this direction, okay? Here, the storms are coming, and we have very high Andes Mountains right here, okay? So what do you know about the Amazon?
The Amazon is very.
Usually a lot of rain,
Yeah.
because these storms are coming here, and they're going up, especially in this area. This is where you get a lot of rain, because the air masses have to climb over the Andes Mountains. We get expansion and cooling, rain. Going down the other side, the descending air is dry, okay? That's one factor here. Another factor is this cool ocean current along the side here. It doesn't allow for a whole lot of evaporation for any sort of rainfall in this area. And so these are types of factors that can influence a lot of things. So once again, look at this, where deserts are. Desert here, desert here. There's a little bit of desert, not too much, but mostly over here. In North America, in the American Southwest, Sahara Desert, Middle East, etc. These are close to 30 degrees north latitude, okay, where that descending air mass happens to be. But there's other things. If you look at the Gobi Desert, it's a little bit further north. It's still not too far north from 30 degrees north latitude. It's more close to about 35, 37 or so. But it has a double whammy, okay? Because in this area, it's not only the descending Hadley cell, that dry air, but also a rain shadow from what is right here. This northern part of India, the Himalayan mountains. Okay, here storms come, monsoons come from here, they hit those mountains, and therefore you get a lot of rainfall, okay, on that side. Going over to the other side, any of the air that gets over there is pretty dry, okay, because it's already been all the moisture's been pretty well squeezed out.
Is that, like, just to clarify, so in the Sahara Desert, there's like a distinct line between the Sahara Desert and the rest of Africa. Is that just because of the?
No, it's a gradual increase in rainfall.
I see, okay.
Okay, yeah, because as I said, that global circulation that I showed you with the air masses rising, falling, these things shift 23.5 through the seasons. Okay, so they do shift north and south.
I see.
Okay. Now, even here in California, if you drive down Niles Canyon Road, okay, that's sort of going from west to east. What do you see if you're going from Niles to Sonoma, okay? What do you see on the right compared to on the left in terms of vegetation?
It's like trees right on one side.
There's
and then
trees
like-
where the creek is and there's,
Well, they're not just only on the creek, they go up the mountainside.
Yeah.
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 It's like
But
very.
over here, mostly grass, right? Okay, why do you think that is?
Is it because?
It's not a rain shadow. In this case, it's not a rain shadow.
Is it?
But it does have to do with soil moisture.
Is it because towards?
You have to have enough moisture in the soil to support the growth of trees. Trees require more moisture than grass does,
Is it because
right?
since it-
But here you have this valley. What makes a difference in the amount of soil, moisture in the soil?
The amount of
It
precipitation.
collects at the bottom.
What did you say?
The amount of precipitation.
No,
for-
that's a small area, they get pretty much the same precipitation.
The
If it were a
water.
greater distance, we could say it could be precipitation, but then we'd have to explain why there's a difference in precipitation. They're basically, both sides are getting about the same amount of rainfall.
It collects better where the creek is.
What?
It like collects better because it's a valley-ish.
Why would it do that? Yeah, no.
Does it,
Okay,
is it the difference within?
where is the sun?
The sun is,
You're
for us,
going through there.
23.5 going.
Well, we don't need to worry about degrees here,
Oh, okay.
but, let's say, okay, so there's the creek. Let's say that this is south, this is north.
Oh,
Sun is going to be over here
okay, so.
most of the time, okay?
Since it's
So
shining-
this is getting pretty direct sunlight, right? Whereas this side here, it's at, not part of the day, it's in the shadow, okay? It's in the shadows over here. So even though they're getting the same amount of rainfall, they're not getting the same amount of intense sunlight. And that influences soil moisture. There's higher evaporation over here. Greater evaporation here than there. And that influences it too. Now, let's look at it north and south. Okay, let's take 680 and go up and visit me. Okay, I live in Danville. Go to, going toward Functional, going to Pleasanton. Okay, you look at that side, that side. What do you see on the west side? 680. In terms of trees, vegetation.
Isn't it like tall trees?
Mostly find them on east-facing slope. You know, there's a lot of trees over there. Whereas on this side,
It's smaller.
it is mostly grass. You know, there's oak trees and ravines and everything, but looking at it overall, this is pretty much solid trees on the east side. But over there, or not the east side, on the west side of 680, but it has a bunch of grass over here. Why would that be?
The amount of.
Because now they get the same amount of sunlight, okay? Because the sun is coming up in the east, goes over, and it drops in the west. Now in the early morning, of course, let's change this a little bit differently. So here's east-facing slope, 680. This is west-facing slope. So as the sun comes up and goes over and disappears, well, first of all, in the early morning, it's getting pretty direct sunlight, but by the time the sun gets over here, it's that side that's getting the direct sunlight. So now both of them have about the same amount of sunlight. But why is this over here drier than this over here?
The time of day.
It has a lot to do with temperature.
Yeah.
This side over here,
It's cooler.
when it's getting direct sunlight, that's in the morning.
Yeah.
What are morning temperatures like?
Morning temperatures are really.
Takes a while for it to warm up.
Yeah,
By the time it warms up, this is over here,
it's hotter already.
and this has now high temperature compared to that. And so there's greater evaporation here than there. Okay, now so all this is, what's this got to do with biology? Well, the things that you see growing, they're not there by accident. You know, there's things that explain them, and it has a lot to do with the factors that govern temperatures. Okay? Yes?
How would you define rain shadows?
Okay, it's a dry area that's downwind from the mountainside. Okay, it's the slopes, and you see it in South America, southern hemisphere. That would in the northern hemisphere, the rain shadow is mostly on the east side of big mountain ranges, whereas in the southern hemisphere, it's the other way around, because the wind patterns on the southern hemisphere are just the opposite of what they are in the northern hemisphere. Okay, so this is why we have a rain shadow in the Andes Mountains that's on the coast. It's on the west side, not on the east side. Okay, now if you look at North America, with the Rocky Mountains, what do you have on the west side of the Rocky Mountains?
Rocky Mountain.
It's not really desert, but it's grassland, okay? it's still, and the closer you get to the Rocky Mountains, the less rainfall there is. And so it's short grass, high plains, we call them high plains. But further to the east than originally, that was tall grass prairie. So there are species of grass that got more water, therefore they grow much, much higher. But as you get to the, it's still rain shadow, it's still dry, okay? And because on where the Rocky Mountains, they're also getting rain that moves up from the Gulf of Mexico and hits storms over there. Now, what spawns thunderstorms? We don't get too many thunderstorms here, but in the Midwest right now they have a lot of tornadoes because these thunderstorms are producing it. Where is that rainfall coming from? Well, it's moist air from the Gulf of Mexico, moves up, and during the day, in the afternoon, the ground heats up quite a bit. And so if the ground heats up, the air just above the ground, moist air, it starts to rise because it expands. And as it goes up, then you have cloud formation because it's cooling, and then that develops thunderstorms, okay? And so all those things, there's even more to the story than what I'm telling you, but this is enough. I just want you to have the idea and understand that there's certain geographical factors, climatic factors determine where these biomes happen to exist. So a biome, for the particular organisms that are in a particular biome to exist, for one thing, they have to be able to survive there. Okay, conditions have to be just right for them, and not only just survive, but they have to reproduce. Okay, although you find, and I've already mentioned this before, with redwood trees, coastal redwoods, we find them here in Fremont, you know, but they have been planted. They didn't reproduce here, okay, because the conditions, moisture conditions are not good enough for them to reproduce. They can reproduce over in ravines in the Santa Cruz Mountains and on the way up to Oregon, because of mostly because of moisture. Okay, but it also depends on the ability of the species to get there. So there's a little bit of historical background as to where things are. You know, for example, where do you find polar bears? Where's polar bears?
Polar bears in
Antarctica?
Where?
Antarctica?
Arctic.
Antarctica?
I don't think you'll find any polar bears in Antarctica.
North Pole, Arctic.
North, Arctic, okay, so Alaska, etc. That's where polar bears are. But conditions are okay for polar bears to exist in Antarctica. Why do we not have them there? They evolved, historically bears evolved in the northern hemisphere.
So they travel.
But now to get to the southern hemisphere, they have to go through tropical regions, right? In other words, there's just no way for them to disperse there. And there, even though it's favorable habitat, you don't have them there because of historical reasons, evolutionary historical reasons as to where they evolved to begin with. And they don't have the ability to get there.
Speciation?
What?
Speciation.
Speciation, yeah, because grizzly bears and polar bears are sister groups. Okay? And grizzly bears, once again, northern hemisphere. Okay, this is remember when Pangea broke up? Okay, broke up first of all into a northern Laurasia, southern Gondwanaland, and the bears. Once dinosaurs, major dinosaurs, are out of the way, 65,000 million years ago, then bears started evolving, but they were in the north. Okay, their ancestors came from. All right, so just looking at these major biomes. Okay, so I'm just going to go through the major conditions and locations of the major biomes on Earth, based on, usually named for the type of vegetation, and of course they contain many different ecosystems. Okay, so these biomes, when I speak of biomes, it doesn't mean that the whole biome is, in terms of its vegetation and communities, that it's uniform. In fact, most biomes consist of several different ecosystems, okay? But still looking at the broad area, what is the major type of plants that have to be there? So this is a map showing the major biomes, and notice here, once again, deserts. That's desert. That's desert. This is desert. And over here, that's where the Atacama Desert happens to be on the coast. So
is the line part in that graph just desert and something
Yeah,
else?
and so what comes next to the deserts is grassland.
Oh, no, I mean like there's like line parts within like some.
Like that?
Yeah, like that.
Yeah, it's mixed.
Okay.
It means you have sort of mixed like that. Or is that what it, yeah, you have both.
Okay.
Okay, so just looking at tropical forest. Now, the tropical forests are all located within the tropic zone, 23.5 degrees north and south latitude from the equator. And this map right here shows where the areas that are classified as tropical forest. And we have, three different subtypes of tropical forest. Some of them are rainforest. Some of them are seasonal. In other words, they have a dry season and a wet season. And then you also have a few tropical forests that are dry forests. They don't have as much rain. But nonetheless, they're all regarded as, especially the rainforests. These are really lush. A lot of different species. In fact, the highest amount of species variation happens to be in these particular zones. And they're very fragile. The soils are very thin. Okay, what it means is not a whole lot of nutrients. That's because of the nutrients being leached out by rainfall. So they lose a lot of moisture. Okay, and they're being destroyed at a very, very fast rate right now. And that's, if it keeps going the way it is, then within 10 years, there's probably not going to be, except for little tiny patches here and there, most of the widespread tropical forests are going to be gone.
What are examples of dry forests inside the, like dry?
Okay, I think like in Yucatan, Mexico, that's an area that's a dry forest. Okay, it's still tropical, but they have a dry season, and that sometimes, and the trees will lose their leaves not because of cold, but because of lack of rainfall. And so they are deciduous and they drop their leaves during that time. And then when the rains come back, they regrow the leaves. Also in the tropical areas, it has less rainfall. Because even though, this is more interior, the further you get away from the sea, from the ocean, the less, rain you get because of evaporation off of the ocean, okay? So even though I emphasize that there's a lot of rainfall in the tropical areas, that's just a generality. You still have areas where they have less rainfall, still, although they're 23 degrees within that tropical area. And so this is mixed. It has not only grasses, but also patches of forest, okay? So it's mixed in together. And there's 3 seasons, usually in the savanna. There's a cool, dry season, a hot, dry season, and then a warm, wet season. This is also a place that has, the savannas, they have large herbivores, okay, like zebras, gnus, and so forth. And frequent fires, okay? This is one of the things that keeps down the woody growth. The woody growth is still there, but there's enough fire to keep this as grassland. And these are once again located, a lot of them in Africa, and some here in South America as well, and in India, and in Australia. So large herbivores. And this large herbivores is actually true historically of even temperate grasslands. But human activity, we think, or climate change in the past, let me see here, past 20,000 years or so, pretty much has decimated in northern grasslands, yes.
So are they neighbors with your tropical forests?
They can be, yeah, they border on it. Because what you have with the tropical forest is that there'd be a gradation from being a real rainy forest into a dry forest into savanna. It doesn't have that type of zonation. And this is just another picture of what savanna would look like from Africa. Large herbivores, which are disappearing at a very fast rate. And then, of course, the deserts, which I said. And deserts can be, the main thing about the deserts is low rainfall. But they can be cold. They can be cold deserts, hot deserts. but they're located in that zone real close to 30 degrees, north latitude and south latitude. Here's the range I put, and once again, that's a generality. And the type of plants, they're sparse vegetation because of low rainfall. And the vegetation is adapted to, they're drought resistant, usually have either real deep roots, or they can store water, like cacti. Reduced leaves. In fact, do you know what the leaves are on this cactus? The spines. Those are leaves. Spines are leaves, okay? But they're very, very, very reduced in size. And as a consequence of the reduction, another thing for photosynthesis is that now the stem has become very wavy, okay? A lot of indentations, increasing surface area for photosynthesis, okay? Because the epidermis cells do have chloroplasts and they're photosynthetic, but they can store that. Type of animals, relatively small, mostly seed eating, okay? Because there's a lot of seeds there. And usually have very well-developed kidneys with long loops of Henle, okay? And once again, the map showing where those deserts are mainly located. Then chaparral. This is habit around the Mediterranean. It's in the chaparral. Chaparral is the name of the biome, but the type of climate is referred to as Mediterranean climate. Okay, because it's similar to what's in the Mediterranean area. Okay, so this area of North Africa, southern part of Europe, southern part of Chile, okay, further south, and of course California. They run along in there too. And tip of South Africa is another place of chaparral, and the southern part of Australia, all right? And so this is within 30 to 40 degrees north latitude, and so it has shrubby vegetation, frequent fires, and our fires here are getting even more frequent. And a lot of these plants are somewhat resistant to fire. How many of you know what manzanita is? Type of bush around here. Oh, you've seen it every time you've gone out hiking. There's bushes, shrubs that have very sort of reddish bark, smooth reddish bark. You know what I'm talking about?
Yes.
You guys don't get out much, okay? Because they're all over the place.
Yeah.
Okay, but that smooth reddish bark, I mean, it's not rough at all. It's very smooth, and it's sort of
like
brownish red. Brownish red.
Do they?
That's manzanita. We have many different species of manzanita around here. We also have a tree that's related called madrone, and but these are trees, and they also have that smooth reddish brown bark. That bark is fire resistant. Okay, doesn't mean they don't burn, but it's sort of fire
The
resistant.
bark is like silky, like you can like rub it, right?
Yeah.
It's like silky. I don't know how to describe it. But
Yeah. And so that's what we have here. So moderate temperatures all year round. Also, what's characteristic of the timing of precipitation, because usually all the chaparral areas, they have short period of winter rain and a long period of no rain at all throughout the summer. And that's exactly what we have here, okay? And that's very characteristic of this particular biome. Short wet season, which we've been, last couple of years, been sort of cheated out of, and long dry season. This year we had a little bit more rain than we did last year. And it doesn't mean, once again, when I say that we have these biomes, it doesn't mean it's a uniform habitat. So this is like here in California, you still have redwood forest, okay? So that's still an ecosystem that within the chaparral biome. But we also have lots of chamise and coyote bush and other things that are growing on the hillside, along with grass. Then in the interior of a lot of continents, like right here, Pampas in Argentina, and the Great Plains up here, a little bit in the Big Basin as well in Nevada, southern Australia, and of course, north of the deserts, southern Eurasia, across Russia, Ukraine. This is grassland, temperate grassland. It's similar to savanna, except for the winters here can be very cold. And they do have seasonal droughts, and just like the savanna, fires. The fires is what are real important for keeping woody vegetation down, okay? Woody vegetation. And this is historically. Now, some of these grasslands are starting to become changed because of fire suppression. Just tell you some relationships here. Western Oklahoma. Originally, Western Oklahoma was grassland, like this. Not a whole lot of trees, but because of fire suppression, what has moved in there is juniper trees. Okay, they have grown over there in the last 150 years. Juniper trees have very deep roots, very deep roots. They can take out a lot of the groundwater. And as a consequence of that area having, in western Oklahoma, having more and more juniper, the juniper were prevented from growing there because of natural fires. Okay, now with fire suppression, we get these trees, and they have lowered the water level so that many streams in that area, they were small streams, some of them were seasonal streams, but now what streams that used to run all year round have gone underground. The water table has dropped so much because of the water that's been sucked out of the ground by the junipers, okay? So things change, okay? All right, and so deep productive soils. Unlike in the tropics, these soils are pretty deep, and this is one of the reasons, so they're very nutrient soils. It's taken thousands of years for those soils to evolve, and with our, that's where we mostly find a lot of our farming, okay, is in this area. So a lot of that grassland has been destroyed, used for farmland, and a lot of the rich productive soils are eroding away, okay? All right, just another picture of grassland. And it's very hard to find any place in North America where you can go miles and miles and miles in a place like this. Usually they're just tiny little patches that are left anymore. Okay, temperate deciduous forest. They're at the same latitude as the grasslands, and they border the grassland. Here, we mostly have the grassland right here on the west side of the east side of the Rocky Mountains. But then over to the coast, this is deciduous forest. Most of Europe is that way, and eastern China, Asia, there is mostly deciduous forest. So this particular biome, cold winters, okay, just like, because it's at the same level as those grasslands, so they have cold winters, but they have more rain, okay? And the rain is distributed throughout the year, whereas in the grasslands, it's less rain. And so here it's mostly rainfall, okay, that is contributing to that. And the soils are real rich because the trees are deciduous. What that means, deciduous, is that they lose their leaves during the winter. So they lose their leaves, therefore you have this carpet of leaves in the fall, into the winter, and then in spring, various types of organisms are breaking that organic matter down when the temperatures are higher, and that's what's contributing to the rich soils. They're have a lot of organic material there because of the thick leaf litter that is gathered underneath, right? And then going further north, the boreal forest. There's a Russian name for this, taiga. That's also used quite a bit. And this is centered along that region of 60 degrees north, where we have a circulating air mass is going up, okay? And that's where, as that air is going up, then the gas expands and we get rainfall. And so this has a little bit, still not as much as in the tropics, but this is also further north where the temperatures still remain rather cool. So not only do they, although there's far less rain than in the tropical regions, there's also far less evaporation. And therefore, really what matters to plants is moisture availability, not necessarily the amount that falls. It's availability. And so with less evaporation, they're more available. So this is north and south latitudes. You don't have a whole lot of it down in the southern part because that 60-degree mark is way down here, okay? So although this map doesn't show it down here in southern, because I've seen it, Down here, southern tip of South America, it does have conifer forests. Not the same type of conifers as we have up here, but it's a different type of species that's prevalent through the south. Okay, so short, wet summers, soils thin, acidic. Why acidic? Because cold temperatures, soil still stays relatively cool even during summers. That does not allow microorganisms to break organic material down completely. And so you get a lot of organic acids in the soils from not so rapid decay of leaf litter. And has very little undergrowth, okay, under the trees. And this is another picture of boreal forest that's from a textbook. I don't know if it's your textbook. It's unfortunate that they put these here because these are redwoods.
That's what I was thinking.
Yeah, these are redwoods, and those are not located in the boreal region. Your textbook has a few mistakes in it. And then tundra, okay? Tundra. So what we have here with the tundra, it's in the high north way up here. Okay, you don't have it down in the southern hemisphere because, as I said, these continents here are, all the continents on Earth are sort of geared toward the north. So Antarctica's way down here, okay? Because this is about 60 degrees south. And so they're situated up here, and it's mat-like vegetation, no trees, very cold, long winters, okay? Not a lot of precipitation. They have short, cool summers. Not a whole lot of precipitation, but also not a lot of evaporation. And so during the summers, there is quite a bit of water available, simply once the ground sort of thaws out. Further to the north, permafrost. The ground never thaws out, but it's starting to now. Okay, it's starting to now. In fact, mostly over here in Siberia, they're having a lot of trouble with, because they have villages up here, and as this permafrost has disappeared, the buildings are starting to sag and fall down because the soil is moving. And furthermore, we're afraid that there's a lot of vegetation that has in here that is not, that is storing a lot of carbon. And if it starts rotting, decaying, then this is going to be another carbon input into the atmosphere. Okay? All right, so those are the major zones, terrestrial zones. And these repeat themselves if you're going up a mountainside, okay? So if we're in Africa, Mount Kilimanjaro, it's a very, very tall mountain. Starting at the bottom, you would be in tropical forest. You come up into dry forest, into grasslands, and then tundra near the top, and then Arctic regions. And you do that also in mountains. Here in the Sierra Mountains, you can see that there's a zonation of vegetation as you go up the mountain. First of all, you're in grassland, then you're in oak forest, then you're in pine oak, then pine fir, and then at the very top, above the tree line, it's tundra, okay? And so this also happens up and down mountainsides. Well, there's also biomes in ponds and lakes, and so, which are different than the terrestrial part. And so what type of stratification of life you have there is vertical, okay? Instead of being horizontal on the surface, going from north to south, instead the zonation is top to bottom. Because and it's divided, if it's a deep lake, not the pond up here. If you go to the pond up here, it doesn't work. So it's a big lake, all right? You have the photic zone, but light only penetrates down so far. You get down far enough, then there's no light. The aphotic zone. And therefore, this is in deep lakes. And so all the photosynthesis takes place up here in the photic zone. And that is what's producing the food, the organic material that everything happens to live on. Furthermore, you have this, the warmest water is at the top, and it gets colder as you go down, okay? Yes?
So this would be something like Lake Ontario or something?
Yeah, Yeah, and Lake Superior, those types of lakes. There's a decrease in temperature as you go down, and also the water not only does it become, well, as it's cold, it's also denser. Now, this creates a problem with circulating nutrients back up to the top. As things die up here, okay, algae die, they sink down to the bottom. And so these things are taking out of the surface of the water magnesium, phosphorus, and other materials that's necessary for life. And therefore, and this doesn't circulate back up too much, so it goes down. All right, and as the temperature decreases, it does fairly rapidly until it hits a certain point called the thermocline. And then the temperature still decreases, but not as rapidly. And I'll show you a picture here, next slide. All right, this is showing temperature with depth. So up near the top, this is where it's warmest, and then there's fairly rapid decline in temperature until you reach right here. This is the thermocline. Then the temperature doesn't change too much as you go down. Now, this, so the photic zone and aphotic zone still divided up into biomes. Namely, near the shore, this is called the littoral zone, okay? This is the one that has the highest species richness, highest number of living things near the shore. Out here in the limnetic zone, indeed, you do have algae, but here you have even plants that can still, water plants that can still get some of the sunlight. But out here, it's up in the limnetic zone, be it things like diatoms and other types of the small algae. But when they die, they drop down to the bottom, okay? And they contribute to sediment down here in what is called the profundal zone. So the profundal zone is down where there's no light, but there's things living down here, but they're all detritivores, okay? They're living off the death of organisms that die up here and float down. And so there still is life down here. So this is the type of zonation and the biomes that you have in big lakes. Now, as I said, one of the problems here is if it's a real big lake, out in the middle, there's not a lot of nutrients to live on, okay? For the simple reason that these organisms die, they take everything down to the bottom. But there's 2 times throughout the year that this can become a very rich zone because we get turnover. One of the reasons we don't get too much turnover is because up here where the water is warm, it is also lighter, okay? Because when you warm something, it expands, whereas down here it's cold, it's dense. And therefore you won't get dense water from down below circulating up here unless something changes. And that happens twice a year, okay? So especially if we're coming into spring, what happens in these lakes, we have ice up here where there's snow. As that melts in spring, this is now cold, dense water that is flowing into here because we have a layer of ice up here. Down below, it's not ice, it's about 4 degrees, it's still cold, but this up here is even colder. And as it runs into this ocean, or into this lake, it is dense and it moves down, pushing this water up. And so you get this circulation like this that brings nutrients from the bottom back up to the top, and you get an algal bloom. Okay, algae will grow, and then you have other microorganisms that feed on the algae and just for a brief period of time. That also happens during the fall. There's a fall turnover. But in this case, it's because the top waters, okay, this is cool water down here, but as the air temperatures cool down, this on top becomes cold, dense water, and then we get another turnover, okay? Because this water will drop and push this water up, and in the fall, there will be a short algal bloom here as well. The winds contribute to it as well, blowing the surface waters around. All right, and we're not going to worry about these 2 words. During the summer, things are pretty static. Okay, warm water on top, no circulation. Now, some other terms as far as big lakes, they can be eutrophic or oligotrophic. Usually oligotrophic lakes are relatively young lakes, okay? They've formed recently, and they're, sometimes can be pretty deep, but they're relatively nutrient poor and deep, okay? Like when you go up into the Rocky Mountains, you can find some of these lakes up there. Nutrient poor, but as the lake gets, evolves, then we get nutrient running into, from rainfall, nutrients being dragged into the lake as it flows, water flows in from the surface, and it starts to become nutrient rich. And therefore, you can't see through the water because of the growth of algae, bacteria, everything like that. And that becomes eutrophic. Furthermore, in the deeper part, there's so much decay, bacteria that are living off of the decay that they are depleting all the oxygen down on the bottom of the lake. So it's the only thing that's really living down there are anaerobic bacteria and in the profundal zone, especially during the summer. And sometimes if it gets, a eutrophic lake gets bad enough, it can deplete enough of the oxygen that you have fish kills, okay, because they suffocate. Now, some of this eutrophication is natural, but since humans have moved into the area and their technology, it has really increased, okay? Because of our farming practices, we're putting all sorts of fertilizer on surface for crops, and that gets washed into these lakes, and it leads to eutrophication real bad. Some of these lakes in the last, that were originally when Europeans came here, they were originally oligotrophic lakes, but because of human activity, they have become very, very polluted and eutrophic. There's been a few of them since the 1960s that conditions have changed, and they're going back to being an oligotrophic lake. There are still some good stories here, okay? But all this is coming from erosion from our farming, and we put all this phosphate and nitrogen fertilizers, which cause algae to just go wild, you know, in these lakes. Okay? And the last thing is going to the oceans. Similar to deep lakes. There's vertical stratification, but the zones are called something different, right? They're given different names. We still have a photic zone and an aphotic zone. All right, so near the coast, which corresponds to the littoral zone, is called the intertidal zone, okay? That's where most of production of photosynthesis happens to be. Most of the life you find in the ocean near the continents, shores.
No.
Yeah. Further out, this is oceanic zone, so this is an neritic zone up here. Intertidal, let me jump back here. Neritic zone is close to the shore. The intertidal zone is actually, because of the tides, it's constantly changing. Okay, sometimes it's underwater, sometimes it's not. Okay, and so that's a rough place to live.
So like the coast?
Yeah, that's right next to the coast. Because some of it might be exposed, and then a little bit later in the day, the tides come in and it's underwater. And so critters that live there, they have to adjust to being in the sunlight, being in the water. And it's a rough place. Further out here, neritic zone, that is more stable. Okay, someone had their hand up.
I was just asking.
What's that?
So the neritic zone is where most life is?
Yeah, this is more stable.
Or it's mostly underwater?
And this is where, like a lot of the brown algae, red algae, they'd be located out here in this area. And then you get further out into the ocean, then it's the pelagic zone, and way down at the bottom is the abyssal zone. This is down in permanent dark, and some of these places can get really, really deep sea trenches. So out in the middle of the ocean, there isn't a whole lot of life. There's life there, but as algae die and the other microscopic organisms that feed on them, they would drop down into the abyssal zone. And there are things down here, but they live on the decay that's falling from the top. Okay, so the deep ocean, middle of the ocean, mostly desert. There are some places, however, that are due to upwelling that will bring some of this deep nutrients back up to the surface, just like the spring and autumn turnover on big lakes. And these areas where we have this upwelling has bringing up nutrients from the bottom to the top, leading to a lot of photosynthesis, which attracts the fish, and they're good places for fishery. And some of these places happen to be like Cape Cod. Does everyone know where Cape Cod, Newfoundland is?
The east of Province?
East, it's in Canada. Cape Cod, United States, Connecticut, that area. And what is happening here is there's a series of undersea ridges in this area. So we're gonna let this be north, this south, along the coast. Some water level. And you have a series of mountain ridges in that area, underwater. But coming from the south along the shore is the Gulf Stream. Okay, it's heading north. So as this water hits these mountains, it's deflected upward. And doing that, that's taking sediment from down here and circulating it up to the surface waters. And so this was meant by the upwelling, and by taking that nitrogen, phosphorus, magnesium, and other minerals back up to the surface, it encourages algae to grow. Algae then are fed on by other organisms, which are fed on by other organisms, and so forth. And so that's one area that we have that type of, and this is a good place for fishing. Even back before North America was settled by Europeans, there were Portuguese fishermen after, back, I think it was in the late 1400s, early 1500s, Portuguese fishermen would go all the way across the Atlantic Ocean to this area for fishing, and then back to Portugal, because it was a rich area. Another place where this happens is along the coast of Chile. Now what's happening there, along the coast of Chile, in fact, I think I have a picture of that. Yeah, is because of surface winds. Okay, because they're coming down from the Andes. The wind is blowing down from the Andes onto the surface and blowing this top water away from shore. So as this water is being blown away from shore, that brings up deeper water to replace it. And so you get this circulation, okay, because of the wind. There's a circulation here, and that deeper water, which is bringing the nutrients back up to the surface. And so this is an area that is also a very good fishery area. And this is due to upwelling. And just another picture there. It also involves this Humboldt current that is coming up the coast, and the wind then blows it this way, and we get that water circulation. So this is a good fishery area until El Nino comes, almost every 7 years. What happens is the fishery, the fish here sort of disappear when El Nino conditions set in, because these winds stop. They stop, we lose that circulation, and the fish go elsewhere. Okay?
What's El Nino?
What's that?
What's El Nino?
El Nino and La Nina. Okay, these are two. They happen about approximately every 7 years. They alternate. Conditions in the South Pacific sort of change. The temperature in the water changes, and it leads to, I think during El Nino events, we tend to get more rain up here, but not down here. And then with La Nina, then it's, and I don't remember if the ocean becomes, in tropical areas during El Nino, I think it heats up. And with La Nina, it cools down. And that does influence rainfall way up in temperate regions, like here in California, yeah. But the wind stopped, and that's leads to the fisheries crashing there. Okay, I'm gonna stop here, okay, because this is a totally different ecological topic. Looks like you guys might get a little bit of plants in here after all, because this part won't take me too long. On Tuesday, I'll finish it, okay? And so I might bring in plants, I might not, okay, I don't know. But this is where I'm gonna stop for today, because it's a good stopping place. Okay? Yes?
Are you able to find stuff for the,
Well, if I get the list of people who were there. Yeah, so far, you guys signed in?
Yes.
Yeah.
Well, I wonder who has the list, because they haven't brought it to me. I'll ask about it.
I think they were planning on like emailing the professors.
It was what?
Like I remember last time they were saying that they were gonna email the professors.
Okay, well, I haven't received
It's
it
just
yet.
a
But when
lot,
I
yeah.
get it,
Yeah.
I'll put it in the grade book. Okay? Yes?
Is there a lecture plan on Monday?
Yes, there is.